OT then would have been an easy job if we considered using ratio theorem. Hello and welcome to ratio theorem. But before we start with ratio theorem, let's remind ourselves about internal and external division of the line because it forms the backbone of ratio theorem. So let's consider the lines that we have with us here. We have line AB with point P between A and B. So when you look at these two lines, they are different. They are all AB, but they have a point P for the first case in between A and B, and then we have point T on the right side of A and B. So this one will form the basis of internal and external division of a line that will lead us to the ratio theorem. So when we look at the first case, where we have line AB, line AB is divided into 1, 2, 3, 4, 5, 6, 7 equal parts. And if we consider line AB, or considering that A to B is the positive direction, then what does this mean? It means that from A to P is 1, 2, 3, 4 parts, and from P to B is 1, 2, 3 parts. Now, if we have to write this information in ratio form, and because this line AB, point P being between A and B, it is dividing line AB internally. So this one is internal division of the line. So how do we put it down in ratio form? So we shall have AP is to PB is equals to 1, 2, 3, 4 for AP, 4 is to 1, 2, 3 PB, 3. We can also write this as AP equals 4 out of 7 of AB. So this one takes 4 out of 7 of line AB. AP takes 4 out of 7 of AB. So we normally say that P divides line AB internally in the ratio 4 is to 3. That is internal division of a line. Let's consider the second case. So we know that line AB is divided into 1, 2, 3, 4, 5 equal parts. And then this line is, that is, this point T is 1, 2, 3 from B. Now, if we take the positive, we take AB to be the positive direction, then how are we going to put it down in form of ratio? Now, if we consider the AT, that is from point A to T, is to T is to B. T is to B. So the dividing point should always be at the middle. Okay? Therefore, AT is 1, 2, 3, 4, 5, 6, 7, 8 equal parts. And TB, now this one is taking the opposite direction. Remember, we have taken AB to be the positive direction, just like in the first case. Now, this AB being the positive direction, and now we want TB, then we will have to show that TP is taking the opposite direction 3 parts. So the negative sign here doesn't say that BT is negative. It's showing the direction of that vector. We can also write this one as AT is 8 over, because from A to T is 8 equal part, over AB. AB is 1, 2, 3, 4, 5 parts of 5 A, B. Now, if we were to write a statement like the one we have written before, we should write like this: T, point T defines line AB externally in the ratio 8 is to 3. This time you are not going to indicate negative because already the one external takes care of that. So having done that, now we can embark on the ratio theorem. Line PQ and point T. If we assume point T as divided line PQ internally in the ratio of 3 is to 2. And now we want to find the position vector. I want to believe you know what is position vector. So we consider position vector OP, OQ, and OT. Now, if we let OP to be vector P and OQ to be vector Q, OT to be vector T. Now, how do we express position vector OT in terms of P and Q? Now, let's start from where we know. We know that mathematically, if this is the direction, because O means the starting point, so from O to P, that is the direction, from O to T, that is the direction, and from O to Q, that is the direction. Now, line PQ takes that direction. Remember, vector is a scalar quantity because it involves the size and the direction. So, when we look at now the diagram that we have, and remembering the triangular law of vector, then it is true to say that OP, vector OP plus vector PQ will give us OQ. So, we need to show that these are vectors. Now, we are not concerned with this one. Our concern is to express OT in terms of P and Q. Now, what is OT? How do we get to T? So, we can move from O to T directly, or we can move from O, pass through P, and then go to T. And that is the route we are going to take. So, for OT, we can have OP plus PT. Nice. Therefore, OT, we need to know what is OP. OP is vector P. Now, plus PT. Now, this one takes now back to internal division of the line. Now, what fraction of PT is in relation to PQ? It's 3 of 5 over 5 of PQ. of PQ. Now we cannot proceed until we know what is PQ. Now PQ therefore is equal to OQ minus OP. I'm getting this statement from the triangular law of vector. PQ equals OQ. If this one goes to the other side of the equation, shall become negative. Then what is OQ? OQ now is Q minus OP, which is our P. If we proceed like that now, then our OT equals P plus 3/5 PQ, and our PQ is Q minus P. Therefore, we shall have OT as P plus 3/5 Q minus 3/5 P. Now, putting the like terms together, we shall have P minus 3/5 P. So when we minus, we shall have 2/5 P plus 3/5 Q. And therefore, we have expressed OT in terms of P and Q. Now, we want to ask ourselves, if we can look at the answer that we have, what can we say? Because we can see 2 over PQ, which is 3 plus 2, 5, P. And we can see 3 here over PQ, that is 5, Q. There must be a formula which will help us arrive at this answer with minimal or zero calculation. You better relax and wait. Let's consider a general case where we have line PQ with point T dividing line PQ in the ratio of m:n, and try to express OT in terms of vector P and Q. Now, from the example we had, this will be very easy. That means OT will be equals, to start from O to T, we take the root of OP, which is vector P, and then PT, which is m over m plus n of PQ. That is what we have done in our first example. Now, if that is the case, then we need to know what is PQ. From P to Q, we use which root? We move from P through O, then to Q. So, PO is the opposite direction, so we negate vector P. And then OQ is the positive direction, so positive vector Q. So that is PQ, which you can also write it as Q minus P. Now, then our interest is position vector OT. OT, how do we get OT? OT now is vector P plus m plus n of PQ, which is now Q minus P. All right. So, simplifying, we shall have P plus m over m plus n Q minus m over m plus n P. Taking the like terms together, our OT shall be P minus m over m plus np plus m over m plus nq. Nice. So this one, factoring out p, we shall have 1 minus m plus n, then plus m over m plus nq. Nice. Nice. Now this one, then, taking this one, using this part here, up here, 1 minus m over m plus n, getting the LCM as m plus n. 1 will go to m plus n, how many times? M plus n times, then minus m plus n divided by m plus n is 1 times m, then it is m. So we have plus m minus m, that is 0. So we shall have n over m plus n. Brilliant. Now let's substitute that here. So we shall have what we have up there, n over m plus np that we factored out, plus m over m plus nq. This is expressing a general case, OT, in terms of P and Q. Therefore, OT now is n, gonna have n over m plus n p plus m over m plus n q. This is what we are calling ratio theorem statement. How can we use this ratio theorem to solve the case that we had? The example that we had, m was 3 and n was 2. Then it means that m plus n is 5. 3 plus 2 is 5. Now, OT then would have been an easy job if we considered using ratio theorem. So what is n? N in this case is 2 over m plus n 5, p, then plus, what is m? 3 over. Therefore, ratio theorem is very important when you are expressing a position vector of a point that defines any line into a given ratio. I want to stop at that point. Don't forget to like this video and share widely. Until we meet in our next tutorial, is a bye from me and a lot of